I figured out I really like teaching like with the sharing screen and writing on my screen. It gives me more space to write things for one, and I think it's more clear that way. I don't have to worry about lighting or like reverb in the playroom or anything like that. So I kind of like it because it's nice and clear. So I'm going to try that today again. Let me see. Let me get everything set up. Okay, so what we are going to do today is we're going to finish that 12.1. So we did start 12.1 on Friday. And I did say I was going to open some homework that wouldn't be due. Just, I was going to open it so you could get started early, but I ended up not opening it because I realized I left out a pretty important thing. Like I possibly mentioned it, but I didn't really, I didn't talk about it enough. I don't know how else to say that. So we're going to go through a problem from 12.1, or probably a couple of them. And I'm going to mention this extra thing that you're going to need to know so you can do your homework and stuff like that. So what I am doing right now is I am pulling up some notebook paper. Let's see. I'm going to pull up a new page so I can write on it, and then in a minute I'll share that with you. Okay. All right, I got that set up, so then I will share it. Share screen. Okay, so you should be able to see my OneNote notebook screen up. And let's review what we did in class on Friday, and we'll go a little further with it too. So in 12.1, so we're still here. You guys, what we talked about, if you weren't here and you didn't catch the video, or you just don't remember or didn't get a full understanding. So what I did, I started by just drawing a random graph of a function. And we talked about how the function's changing at different points and what the derivative would be at those different points. So, like I picked a point maybe here. I picked these points here. I picked multiple points on the graph, but we talked about what the derivative would be at those points. And we couldn't know specifics because this function didn't have a specific equation. But we could talk about whether the derivative was positive or negative. So we decided here that, remember, derivative being slope of the tangent line, down at this point, the tangent line that we would draw at that point would be increasing. This one's increasing pretty fast. But because the tangent line is going up, I know the slope there, or the derivative. So the derivative of this function would be positive. I don't know what number, but I do know it's a positive number. Oh, I didn't get a negative point in there. Jack, Gracie has my t-shirt in her mouth. What? This dog, my goodness. I love her, I really do. Anyway, guys, let's do this point. I need a decreasing point. So the tangent line at this point, if I drew that, notice the slope of it would have to be negative because it's going down. So we found out the derivative is negative in places where your graph is decreasing, and it's positive, like over here it would be positive because your graph is increasing. But then we also talked about these changing points, where if I drew a tangent line at these points, that it would be horizontal because it's not really increasing or decreasing there. Because the slope of that line is horizontal, it would be 0. So we have some points where our derivative is 0. We have some points where it's positive and where it's negative. Come here, girl. There you go. Good girl. That was a good drop. You shouldn't have had it in the first place, but you know, whatever. Okay, anyway, so on a graph, we realize that these are pretty easy to find, but we could find them algebraically. So what we did was I gave you a function, and so now I will give you a function. We'll do a new function, not one that we did last time. Let me get a different color. So let's say that our function f of x equals 12x squared plus 8x. And I want to find all this stuff. I want to know, where is this function going up? Where is it going down? Where is, you know, the derivative 0? As in, so where are the places where it changes from up to down and stuff like that? Okay, so we found that the first step was to take the derivative. So the function, if you're not going to graph it, you know, just put it on a graph. The best way to know what's happening with it is to take the derivative and think about what's happening at different places on the derivative. So we did. We took the derivative of this, and these are all going to be pretty basic power rule for the most part, guys. So we take the derivative here, and we get 24x plus 8. Now, after we take the derivative, we set it equal to 0. And you guys, that's going to be a running theme as we go throughout this chapter, guys. Chapter 12 is basically a lot of take the derivative, set it equal to 0, and solve for x. Now, remember what we're looking for. Why did I set the derivative equal to 0? Because if we look up, you guys, if I can find those places where the derivative equals 0, I can find the places where it changes from increase to decrease or from decrease to increase. Okay, so we're solving for x here. You guys, on this one, notice we get x equals negative 8 over 24. That's just 1/3, right? I noticed some of the homework problems that I'm going to give you might give fractional values for these points, so I wanted to do one with you. I'm going to try to avoid it, but just in case I can't. So you guys, I've got this. I've got x equals negative 1/3. So I have to remember what that means. You guys, what that means is whatever this function looks like, it has a point where x equals 1/3, and that point is where it changes directions. So I don't know if it was going down and then it hits this point and it starts going up, or vice versa. Maybe it's going up until it hits this point and then it starts going down. All that I do know is it changes directions here because this is a point where the derivative is 0. Remember this, finding this point where the derivative equals 0, this is called a critical point. So anytime I say, can you find the critical points of this function, what I'm asking for is for you to take the derivative and set it equal to 0 and solve for x. So here we are, we found our critical point. But remember, we didn't stop there either, because I do want to know what it's doing around that point. So after you find your critical point, you stick it on a number line. So here's negative 1/3. Now what we did was we picked a value over here and one over here, and I tested those values in my derivative. Here's what I'm looking for. I want to know, on the left side of negative 1/3, is my derivative positive or negative? What's that going to tell me? It's going to tell me if it's moving up or moving down there. So you guys remember, it doesn't matter what value you pick as long as it's over on that side. So I try to pick the easiest values I can. So something less than negative 1/3, well, why don't we just use negative 1? That's an easy value to work with. And I'm going to test it. in the derivative. So I'm going to do the derivative at -1. Don't put it in the original function. And let's see what we get. So we get 24 times -1 plus 8. Oh, hold on, guys. I'm getting a phone call. Hello?
Hey, you got a hold of the guy yet?
Sorry, guys. All right. So anyway, I'm back. Here we are. So you guys, remember I'm testing -1 in the derivative to see if it ends up being positive or negative. And remember, I don't even really care what the actual value of it is. I just want to know the sign of it. So I've got -24 plus 8. So you guys, that gives me -16. So it's negative. So I'm going to notate that. And usually I just put a little minus up there. It says that everything to the left of -1/3 is decreasing. All of these values have a negative derivative. Remember, you only have to test one of them. You don't have to test multiple values over here because you know the only way a graph can change from increasing to decreasing or vice versa, the only way your derivative can change signs is through a point where it equals 0. And we only have one of those on here. So all of these, because you found this one had a negative derivative, that means all of that side has a negative derivative. So you can even draw it in, guys. It means that this is decreasing here. Sorry. I have a lot going on this morning, apparently. I didn't realize, but I do. So just give me 1 second. I'm sending a message. Okay, sorry, guys. Hopefully that's the last one. Okay, so notice I drew this. I kind of like to draw a picture up there too. So you can put the negative, but if you really want, if you're visual, show that the graph is going down on that side. Now you guys, let's see what's happening on the other side. I think you probably know that if it's going down here, that it will be going up on the other side. I'm just going to warn you that there are some graphs that go through critical points that decrease, hit a critical point, and then keep decreasing. And it sounds weird, but it's a thing that can happen. So I want you to test all your intervals. So you guys, something over here. Just any number greater than -1/3. You guys, I'm going to pick 0. You guys would always pick 0, you know, whichever interval it's in. It's so easy. So you guys, let's test the 0. So I've got 0 put into the derivative. So it's going to be 24 times 0 plus 8. And that just leaves us with +8. So like I suspected, it is positive on this side, which means the graph looks like this. Now, here's the thing. For some reason, I don't know why it just skipped my mind. When we were talking on Friday, we talked a lot about the increasing and decreasing intervals, which we can see here. But what I didn't talk about was classifying this point. We know it's a critical point, but you're also going to have to classify it as a minimum or a maximum. And it's not really a hard extra step. I think it makes a lot of sense and it's easy to figure out, but you are going to have to do it. And I don't know why I didn't tell you that. So here's the deal. If our graph is going from down to up when it goes through this point, can you see that that point has to be a minimum? So when I say minimum, let's go back up to my graph that I made for a minute. This point here, for example, it's a minimum because it's lower than all the points around it. It's not the lowest point on the graph. Notice this graph actually goes down forever, but it's what we call a local minimum. In this general vicinity, it is the minimum point. This point up here, well, that's a local max. And you can always tell if you draw that little picture on your number line. So you guys, this point for us, the -1/3, is a minimum. So let me show you ways you're gonna need to write your answer, or what they're gonna ask for. They might ask for this. They might say, and if they call it minima, that just, it's plural. You know, they're assuming, or they're not, they don't want to tell you if there's one or more than one. You know, they don't want to give that away. So they'll say, are there any local minima? And you say, oh, as a matter of fact, there's one, you guys. And you would say it occurs at x equals -1/3. It's always at a critical point. Your critical point's always either going to be a max or a min. So I say, yes, it's at 1/3. If they ask, so remember, you only give the y value if they ask for it. So they might ask, well, what's the value of the minima? Or they might say, what's that minimum value? Well, that's when if it says value, that's a hint to find the y value at -1/3. Now, if -1/3 is your x and you want to find the y, remember to just find a y value on the function, you put it into the top. I'm not testing anything here. I'm just finding a value. So we can find it. And again, I know this one's a fraction, just, it'll be fun. So let's put it in. We got 12 times -1/3 squared plus 8 times -1/3. Okay, remember to square a fraction, you just square the top, square the bottom. So you have this 12. This negative will go away because of the squared. You'll have 12 times 1/9 plus, or I guess it'll really be minus, huh? Let's just call it -8/3. I know it looks bad right now. It's really not going to be that bad. Okay, so why don't you just put the 12 over the 9? Oh, yeah, let's do this. Let's do the canceling first. Let's go ahead and take a 3 out of that 12 and the 9. Remember, that is 12 over 1. So that would be 3 and 4. So you could call this 4/3 minus 8/3. So see, not too bad. They already have a common denominator. So you get -4/3. So what did I just find? I found the y value at the critical point. So I say, yes, I do have a minimum. It happens at x equals -1/3. What's the value of that minimum? Well, that's -4/3. It's a y value. I don't think you'll need the y equals or anything, but it is a y value. So that's going to be one thing they ask you. And then the other thing that they might ask is the intervals, you know, like increasing and decreasing. And that is something we talked about. I just, for some reason, didn't tell you to classify the critical point as a min or a max. So you guys, increasing and decreasing intervals. If it said, where is this graph decreasing? Well, you're looking for values that you put a big minus over or an arrow pointing down like I have here. And just remember, it is an interval notation. So for us, the decreasing goes, you know, it goes out to the left forever. So, and remember, these are only in x values when you do an increase and decrease interval. So we're going to go from the left, and it goes all the way to the left. So from -infinity up to your critical point, always parentheses for increase and decrease. And then we have an increasing interval also that one starts at negative 1/3, and that goes on, it keeps increasing forever as x goes to the right. So that's going to end at positive infinity. I think the best way to remember how to write your intervals and not to get confused and try to think about y values or anything like that is just remember it's always left to right. So your intervals is always left endpoint to right endpoint. And if your endpoint's not really an endpoint, if it goes on forever, that's where you get the infinities. Okay, let's see, what else do I want to say? Oh, there's one more thing I want to mention on this. The way it asks the question, so it's going to ask this question. It'll also, every time, because it doesn't want to give anything away, like I said, it'll ask if there's any minima, and then if there is, you say, and then complete the rest of the question. It will always ask for both. So it will also say, well, is there a maximum or is there any local maxima? Well, on our problem, because there's not, you would just say no. So just because they have both questions, it will always ask for a min and a max, doesn't mean you'll always have both. It just words the questions in the same way, because if it only asked for one of them, you would know to only look for one of them, you know? So it's always going to ask for both, and sometimes you will have both. But on this one, we just had the min. So this question, I would just say no and move on. Okay, so let's do another one. You guys, let's do one that's a little more complicated. We haven't had one with more than one critical point yet. So I have it, I just have to reference it real quick. X cubed plus 3x squared minus 9x plus 4. X cubed plus 3x squared minus 9x plus 4. I'm going to write this really fast so I don't forget. Okay, this is the function I want to do all that stuff with, just like I did with the other one. So I've got f of x equals x cubed plus 3x squared minus 9x plus 4. And I want to know all those things. I want to find increasing and decreasing intervals. I want to find critical points. I want to know if those points are minimum or maximum points, and all of that good stuff. So step one is always the same. You guys take the first derivative. Or for us right now, just take the derivative. We only have the one. So take the derivative, guys. Power rule, 3x squared plus 6x minus 9. So first step done. Now, after I take the derivative, what do? I set it equal to 0. So 0 equals 3x squared plus 6x minus 9. Now I need to solve for x. So that's my number 2 substep, right? I set it equal to 0, then I solve for x. Okay, this is a quadratic expression, right? I've got the x squared in there. I've got all those 3 terms. You guys, how am I going to solve this? This is where that factoring comes in. So this is why we reviewed factoring, because I have to factor this so I can solve for x. Okay, so 0 equals, this needs to be some factored version of this. Now, sometimes we can make it easier on ourselves to factor if there's possibly a number we could factor out of all 3 of these terms. Now I could do it as is, but you guys, each of these terms, I could take a factor of 3 out, right? So if I can, I might as well. It's going to make my actual factoring a lot easier if I do that. So this doesn't work all the time, but on this one it does. So what I mean is, let's take these 3 terms, let's take a 3 out of each of them. That would leave me with x squared plus 2x minus 3. And this, notice now, because the x squared's by itself, it's a lot easier to factor than it was with the 3's in there. So let's keep going. All right, so let's see what this factors into. Actually, let me give it an extra line. Okay, so remember how we factor. So we take the factors of the first term, which are always x and x. Those are going to be your first values. Notice we didn't have the coefficient on the x squared anymore, so I didn't have to worry about it. You guys, the 3, because it's on the outside, you don't have to worry about it. It's not part of your factoring problem anymore. So we got the x and the x. You guys, I just need to figure out the factors of -3 that I need. So they need to add up to +2. So I'm thinking probably +3 and then -1. It makes -3. It adds up to +2. So I'm going to get x plus 3 and x minus 1. Okay, so we did the factoring, but we're not done because unlike the factoring review I did, we just factored stuff. We didn't solve anything from there, but I need to take it a step further, right? I do need to solve for x. So if I have 0 equals this, what I have to do from here is I have to set each factor equal to 0. So anytime you factor anything, if it is set equal to 0, the way you keep solving is to set each factor equal to 0. Now, what about this 3? Should I set 3 equal to 0? Well, you can if you want, but it doesn't make any sense, right? 3 doesn't equal 0. So you guys, because this term doesn't have an x in it to solve for, it doesn't affect your solution in any way. So sure, you can say, okay, well, I got to set the 3 equal to 0, but it doesn't make sense. So, you know, it's not going to be part of your solution. Here's what I do want to set equal to 0, the x plus 3 and the x minus 1. So I have 2 factors set equal to 0, so that's 2 separate equations. I'm going to get 2 separate solutions for x. So if I solve this one over here, I get x equals -3. This is a solution for x. If I solve this one over here by adding 1 to both sides, I get x equals +1. So let's remember what we just found. We found the derivative, we set it equal to 0, and we solved for x. We just found the critical points, and this time there are 2. So that's a good first step, right? Finding the critical points. Now I have to do all the other stuff. I have to find out, are these, is one of them a max? Is one of them a min? Where is it increasing or decreasing? And remember, that's where I use the number line. And remember, another way to just say test on the number line, it might say use what we call the first derivative test. Just if it says it that way, you know what to do. And I like calling it the first derivative test because it reminds me that when I do test those values, I test them in the first derivative, or for us, the derivative. So I have 2 separate points now. I need to put both of them on the number line. Make sure they're in order because it's really going to throw you off if they're not. So I have a -3 and I have a +1. So because I have 2 critical points, notice that I have 3 intervals to test now. So I can't just pick 2 numbers. I have to pick a number over here, a number in here, and a number on this side. Remember, I'm going to test these values into the first derivative. So anything less than -3. I'm just going to pick -4. Okay, so -4 into the first derivative. So it's going to be the derivative at -4. So here's our derivative. It's 3x squared. So 3 times -4 squared plus 6 times -4 minus 9. So you guys, your derivative on this one is more complicated. There's more terms. So just be really careful. Okay, so this is 3 times +16. This will be minus 24 minus 9. You guys, 3 times 16 is 48. Then I have minus 24 minus 9. 48 minus 24 is 24. Minus 9, we get 15. And it is positive. So, you guys, for this section over here, to the left of negative 3, all of those values are going to be positive, which means my graph is looking up at that point. Now, remember, these points here, you already know the derivative is 0 there, so try not to test those or think you need to. Let's pick a point in between. You guys, 0 lies in between that interval, between negative 3 and 1, so I'm going to test that. Okay, so the derivative at 0, remember that's going to be super easy for us, because if you put a 0 in for all those x's, all you're going to be left with is the negative 9. So remember, I don't care that it's 9, I care that it's negative. So this area in between is negative, which means the graph is pointing down there. Stop talking to me, I'm busy. Okay, so next we need to pick a value on this interval. So greater than 1, any number greater than 1, you can put in here. So I'm just going to use 2. Let's test 2. So it does take a little longer when you have more than one critical point. There's more testing involved. So let's do the derivative at 2. So we have 3 times 2 squared plus 6 times 2 minus 9. So 3 times 4 plus 12 minus 9. 12 plus 12 is 24. Minus 9 is 15. So we got 15 again. You guys, that's fine. It's positive 15. And so we're going up there again. So you guys, even without knowing what the graph looks like, we never actually graphed this function. You have a pretty clear picture here. So let's use this and answer the questions that it's going to ask us. It's going to ask if we have a minimum point. You guys, we do. You guys notice here at negative 3, we go from up to down, and that negative 3 point would be here. That's not a minimum. But notice here where we go down to up, that tells me that this point at positive 1, that is a minimum. So you guys, our minimum occurs at x equals positive 1. How do I find the value of that minimum if it asks me? Well, you guys, I take that 1 and I put it into the original. So you guys, if I want to know the value at x equals 1, I do f of 1. So I get 1 cubed plus 3 times 1 squared minus 9 times 1 plus 4, and I'll work it out. So you guys, this is 1 plus 3 minus 9 plus 4. So 4 plus 4 is 8 minus 9. I think I get negative 1 here. So I put 1 into the original function, and I got that the minimum value is negative 1. And it occurs at 1, which I already knew because it's a critical point. All right, so what if it asks for a max? This time I'm not going to say no because there is a maximum point here. You guys, so the max, where you go from up to down, is occurring at x equals negative 3. If I want to know the value of that max, I just have to put it into the function. So I'm going to need some space to do that. Let's put it down here. Remember, original function, putting in negative 3. So it's going to be negative 3 cubed plus 3 times negative 3 squared minus 9 times 3 plus 4. Okay, so negative 3 cubed is negative 27. Remember, if you start negative and you cube it, it's still negative. So I get negative 27 plus 3 times 9. So this will be 3 times positive 9 minus 27. There's a lot of 27s happening here. So we get negative 27 plus 27 minus 27 plus 4. Let's see. Did I put that in there correctly? Let's make sure. There's a lot of negatives and stuff going on. I think it looks fine. 3 times negative 3 squared minus 9 times negative 3. Ah, I didn't do something correctly, guys. This should be a negative. I felt like I was missing a negative or a plus or something somewhere. There it is. And yes, you guys found it for me. So negative 27 plus 27, you can cancel those out, but then you have 27 plus 4. So I think we get 31 there. So you guys, the max happens when x is negative 3, but the actual max value is 31. I think if I did that right the second time. So you guys, it might ask questions like this. Where does it occur is always an x value. What the value is always y. So again, where does it occur? At an x value. What is the value? Well, that's a y. What else might it ask? Increase, decrease? So you guys, let's do increasing and decreasing intervals. Let's start with increasing. So go to your little number line. Look at the intervals that have a plus above them, or the ones where you drew an arrow pointing up. So you guys, it looks like everything from negative infinity up to negative 3 is an increasing interval, but also I have another one from 1 to positive infinity. So this is how I would write my intervals. Everything to the left of negative 3 was increasing, and then also from 1 to positive infinity. I don't know if it cares how you put these in. Usually when I have more than one interval in an answer, I union it. So this is kind of like capital U. It's just saying this interval and that interval. It's a union of two intervals as your answer. You could probably separate them with commas also, and it probably would take it fine. But I put the union in there. And there's like a button, like an input template for that, if you want to use the union. We did have a decreasing interval. So go back up to your number line. It's the one with the minus. So it's this one here. We are decreasing from negative 3 to positive 1. So you guys, I think the biggest thing that will get you on problems like this is remembering that, for one, your intervals are only in x values. And look, guys, look up here. Notice that you have a minimum and you put your answer was x equals 1 and a maximum at x equals negative 3. Sometimes people get those confused because you're like, well, negative 3 is less than 1. So wouldn't that be the minimum? Remember, x values only tell you left and right, not up and down. So a lot of times you're going to see where when you compare your two critical points, even though one is higher than the other in value, like 1 is bigger than negative 3, 1 still was our minimum because that's not what it's about. It's about the actual values there. You're just finding where the min and max occur, like where they happen. And that's an x value. And then if they want to know what the value of that is, you just find the y value. Okay, guys, so you can finish. So when I put the homework up, you'll be able to do it now. These are the questions they're going to ask. This is how you answer them in all possible ways. You might not have to put all the information on for every one of them, but this is all the information that they will ask. So yeah, so getting your factoring on, you know, just being careful, guys. And as you look through those, you'll, you know, if you come up with any problems, you know where to find me. Okay, so I'm going to stop share, not new share. I just want to stop share. There we go. All right, you guys, so that is it for today. Do look for that homework. I will be putting it up now because it's time. So look for that, work on it, you know, and I'll see you on Wednesday, same time, same place.